Welcome to Study Guide Forum. Today we'll be talking about solubility of substance, and we're also going to look at some of the calculations that has to do with this. So today we're going to be looking at defining some basic terms that has to do with solubility. One of them is the solute. The solute is a substance which is dissolved in a solvent, while a solvent is a substance in which a solute is dissolved in, or the substance which dissolve the solute. And then we talk about solution. Solution is a homogeneous mixture of the solutes and the solvents. So homogeneous mixture in the sense that physically, when you look at them, you find out that all of them, the liquid appears to be they look alike in every way. Just like when you dissolve your salt in water, you notice that the water remains colorless. You won't know that it's salt until you test it. So when you test it, you know that there's something inside it. So that is a good example of homogeneous mixture. So just like also when you dissolve your sugar in water, it look like water until you test it. Once you test it, you know that something else is inside. So that's a good example of homogeneous mixture. In a homogeneous mixture, everything looks alike. There is no separation in them. Everything look like they mix up uniformly, unlike what we have in heterogeneous mixture, where something like when you mix your starch in in water, notice that always a separation. After a while, the thing will condense, separating the liquid and the starch particles differently. So in this case, we say that solution is what homogeneous mixture of solute and a solvent. Whenever you have a solution that contain a solute that both of them look alike, we say is what homogeneous mixture. So we talk about saturated solution. Saturated solution at a given temperature is a solution which contains more solute that it can dissolve at that temperature in the presence of undissolved solute. So when a solution is saturated, you will see some crystals of what undissolved solutes in it. So when it gets to this point, we say it was saturated. So we'll talk about the solubility. So we talk about solubility. Solubility of a solute at a given temperature is the number of moles or grams that can saturate 1 dm cube or 1000 cm cube of the solvent at that given temperature. It is always expressed in mole per dm cube, and in some cases also in gram per dm cube. Mole per dm cube or gram per dm cube. Because in some calculation they will ask you to calculate the mass, of substance required to dissolve a certain saturate a certain solution. So to form a saturated solution of a particular substance, as the case may be, or in moles. So that is the case in that. So now if you want to calculate, that's the meat of the matter now. This is the meat now. If you want to calculate solubility, how do you go about it? This one of the simplest way you're going to do this is what we have here. Solubility is not something that will make you to be scared. You should not be afraid of solubility because it's one of the easiest thing you can do in chemistry calculation. Now to calculate solubility, you can always use the word mass, which stands for the mass of the substance, and molar mass divided by molar mass times volume of the solution, that is in 1000 dm cube, 1 dm cube or 1000 cm cube, divided by the volume of the solvent given to you. So this has to do with the volume given, and the standard, you know that we normally measure in dm cube, 1000 cm cube, or in 1 liter. Do you understand? We use this thing as our standard of measurement: 1 liter, 1 dm cube, or 1000 cm cube. So this is 1000 cm cube here can also stand for what? 1 liter, 1 dm cube, as the case may be, depending on the question or depending on the question you are giving. So in this case now, um, we're going to look at a few calculations that will help us use this formula effectively. That's what we're going to look at now. We're going to solve some problem that will help us know how to manage this formula we have there. So we have a question here. The first question says that 60 cm cube of a saturated solution of sugar at 50 degrees C was evaporated to dryness. 44.2 gram of dry solid was obtained. So what is the solubility of the salt at 50 degrees C? Now the molar mass of the sugar is 342 gram per mole. So now going back to our formula, the formula we have there is that solubility is what? Mass over what? Molar mass times 1000. So that's mass over molar mass times 1000 cm cube of what? Solution all over the volume of the what? The solvent, also the solution, that depending on the volume given to us here, just like what we have here is a 60 cm cube. So the mass here is what? Equal to 44.2 grams, and then the molar mass, I can say mm, is equal to 342 grams, and then the volume of the solvents or the solution given there of the solvents, we have a 60 cm cube. This is what we have. So this other one is 1000 cm cube, which is more like a molar, the standard volume that we normally use, that is 1 dm cube, 1 liter, or 1000 cm cube, like I already stated before. So in this case now we are going to substitute. If we substitute that, we have mass, mass, that is 44.2, divide the molar mass times 1000 over what? 60. So by division we will have the final answer to be 2.15 mole per dm cube. 2.15 mole per dm cube. If you have to get it in mass, then you can multiply this mole with the molar mass, you get the mass of that, which you already have here, right there. We have it there already. So that means in mole per dm cube, the molar the solubility is what? 2.15 mole per dm cube. So that's the case. Now we're going to look at the second question. We're going to look at the second question. The second question said 4.07 gram of a sample of potassium triiosochlorate 5 was required to make a saturated solution of a saturated solution with 20 cm cube of water at 35 degrees Celsius. Calculate the solubility of the salt at 35 degrees Celsius. So using the same thing, we have the mass. The mass given to us there is what? We have a mass. What's the mass there? We have this as our mass. We say that mass is equal to 4.04 grams. Molar mass, like I say, is mm. Or again, we say is what? 2.5 grams. And then we have the volume given to us. Volume there is what? What's that volume? 20 is equal to 20 cm cube. Now the next thing we have there, okay, this is already there, so we can substitute. What we have is over what? Molar mass times 1000 cm cube over what? Volume given to us, which is 20. So When you divide this, you have 1.67 mole the DMQ. That's the final answer. So thank you so much for being part of the class. And if you have any question you feel that you can ask, you can go down to the comment section and drop your question, or as well tell us where you are watching us from. Thank you so much.